Astronomy Cast, episode 274 from Monday, October 1st, 2012, Asteroid Vesta. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Doing great. Now, you actually sort of jumped into our virtual star party last night, and
I did.
You recommended that people go out and search for auroras. There was going to be a big auroral warning. How do people do that if they want to know when they should step outside and look up and spot the sky light on fire? How should they do it?
Well, there's a variety of different Twitter feeds that you can follow, and the spaceweather.com website, add it to your list of places that you go check out when you're bored. They show the latest photography coming in from different aurora watchers, and they also allow you to see forecasts for solar storms that tell you both when it's interesting to go look at the sun during the day and when it's interesting to go look for aurora borealis at night.
Awesome. And then the other thing, and that is, I guess we wanted to announce this, which is that we've got the asteroid mappers going on CosmoQuest, and so people can actually go and map asteroids from Vesta. Although I guess we're going to talk about Vesta, and so we'll probably get into that quite a bit as well. But where can people go if they want to map some asteroid craters?
You can go to cosmoquest.org, and right off of the homepage we have a link to asteroid mappers. And if you feel like just typing the whole darn thing in, it's cosmoquest.org/mappers/Vesta. And this is apparently going to be a very tongue-tied day. I have no clue what's going on other than jet lag, so I apologize for that.
Say that 10 times quickly.
No.
Okay, well, let's get rolling then. So there's some topics on Astronomy Cast that we wait until we're good and ready, until the science is all in. Well, the Dawn mission has completed its mapping operations at asteroid Vesta, and it's now moving on to Ceres. So this gives us a great opportunity to take a detailed look at this amazing asteroid, report on the science findings, and give you a preview of what's coming next. Well, so this is good. I can't think of a lot of times when we've had a chance to actually report in detail on an object that from when we began Astronomy Cast, a mission has been launched, the mission has arrived at its destination, it has completely studied its target and has moved on, wrapping up all of its observations. I think we've been doing Astronomy Cast for too long, maybe.
Well,
we're getting to the point now that we're outliving missions.
Phoenix did do this as well, except Phoenix sort of went to an object that we've been to a bunch of times before, so it wasn't quite as exciting. So this is the first time a brand new object has been reached.
So then let's go back into the history of Vesta first, before we actually talk about some of the recent stuff. What is asteroid Vesta?
Well, it's one of the dwarf planets, some would call it. We're still debating over whether or not it counts as round once you take into account the giant basins that are in its south polar region. But whether or not you decide to call it dwarf planet or not, it's a very large, what we call differentiated object. It's one that has a core, a mantle, a crust, just like a planet does. And it's considered to be one of the protoplanets in the asteroid belt that just didn't quite make it into accreting enough material to actually grow up to be a real planet. It's actually a full 9% of the mass of the asteroid belt in just this one object.
And the rest is Ceres, right?
Well, yeah, pretty much. Asteroid Vesta is about 23% the size of Ceres. So it's, yeah, there's a whole lot of mass tied up in that one giant asteroid that actually was once considered to be a planet.
Well, how does it compare to some of the other objects that we're more familiar with, like the Moon and Pluto?
It's much smaller. If you try and hold them up side by side, well, the surface area of all of Vesta is only about the same surface area as the country of Pakistan. So you basically have a very large moon with small potato-sized, potato-shaped, not sized, potato-shaped Vesta next to it. It's pretty round, but there's still lumpiness to it. It's more of an ellipse than a circle when you look at it. And most of all, when you look at it, you notice that the sucker's just been really, really beat up. It's had a hard knock life out in the asteroid belt.
And so formation, where do they think the Vesta and I guess the rest of the asteroid belt came from? Is it a destroyed planet? Is it?
See, that's what was thought early on. First Ceres was found, then slowly over time they began to find more and more of these giant rocks that had very similar orbits, and it was thought that they were a destroyed planet. But what we've realized as we've studied them over time is, well, if they were a destroyed planet, they'd all have a lot more compositional similarities than what we're finding. And so it's believed that what these actually are is fragments that formed in the protoplanetary disk in the early solar system, but they never quite gelled enough to form a complete planet. So Vesta is an object that formed. Ceres is an object that formed. Juno, which is another asteroid, is an object that formed. And each of these are discretely formed objects for the most part. There are exceptions. There are chunks of Vesta out there floating around that are kilometer-sized objects, and there's other chunks that have been knocked off of this asteroid or that asteroid. But for the most part, the asteroids are each individual objects that formed out of the protoplanetary disk.
And so then was there any reasonable science that was done on Vesta before dawn? I mean, watching it from Earth, they didn't get a lot done, did they?
Well, we tried as best we could. There's certain studies that we can do of the asteroids, looking at their reflectivity, looking at, well, how much light in this color do they reflect versus how much light do they reflect in this color. And that gives us a sense of what their mineralogy is, or at least at the level of these two things give off the exact same types of reflected light, therefore they're compositionally probably the same at the surface. And we'd figured out that there's a whole bunch of bodies that have very similar reflective properties. So they're probably related to one another. And it's now believed that, well, Vesta is the parent body of a whole series of both meteors that have hit the Earth and other very similar composition baby asteroids that are out there. And it's actually thought that, well, there's this giant crater that we were able to make out with the Hubble Space Telescope, although with Hubble we weren't able to tell if it was a discolored region or an actual crater. Well, now we know, thanks to Dawn, it's a giant crater or basin. Basin is basically a big version of a crater. And when this crater was formed about 1 billion years ago, Vesta lost about 1% of its mass during this impact, and that's formed these other objects that we're seeing.
And so then before the Dawn mission was actually sent to Vesta, what were some of the big mysteries, the big unknowns that scientists were looking to answer?
Well, we were still trying to figure out, are these objects that are differentiated like planets when they get to be this size? So the fact that when we look at Vesta, we're able to tell that it has a crust. It's had not so much volcanoes. We don't see evidence of volcanoes on its surface, but it has had you have shield volcanoes, and then you also have molten rock seeping through the surface. That has happened at some point on Vesta. So we see it had a molten core at one point, and it's differentiated just like a planet, but small. And then there's other weird things that we've been figuring out since then, like it's ringed with giant troughs. We're still trying to figure out how those got there. It has regolith, much like the moon does, and trying to figure out how you end up with regolith on asteroids without that material getting ejected into space has been a tricky business. And then there's just all these color variations across the surface that are very mysterious, and we're still trying to figure out those as well.
So let's talk about Dawn then, and Dawn's arrival. So when was Dawn sent to Vesta?
Well, it entered orbit in July of 2011, and it had taken off well before that. This is a spacecraft that has an ion engine, so it kind of plugs along at its own rate, accelerating very, very slowly as it ejects just atoms at a time. So it got there in 2011. It was launched in 2007. It didn't go very far when you think about it. The asteroid belt is just a little ways beyond Mars, so this was a very slow journey to get there. Once it got there, basically the Dawn mission matched the orbit of Vesta, and then very carefully transitioned from being orbiting the sun parallel to Vesta on its journey to putting itself into orbit around Vesta. And over time, it slowly lowered its orbit so that it could get high resolution images, and then expanded its orbit back out, and now it's on its way out to Ceres. So it was a very slow process.
And so we had that checklist of things that we wanted to look at that you mentioned. So how well was Dawn able to work through some of that science?
Well, it basically, the only thing that Dawn didn't get to do as well as some scientists might like was study the north polar regions of Vesta. And that's simply a problem with, during the time that the mission was at Vesta, that north pole was never very well illuminated by the sun. So that was a problem with the seasonal variations in sunlight, not with the spacecraft. The spacecraft itself performed marvelously well, and the southern hemisphere was very well illuminated. And one thing to point out, when we say northern and southern hemisphere, that's defined by the rotation of Vesta. And Vesta is actually flipped over on its head, and so it's rotating in a prograde manner compared to the planet Earth and many other planets in our solar system. So it's that northern hemisphere defined by rotation that wasn't well illuminated and studied, and the southern hemisphere with its one giant and then second also giant but not as giant basin that got to be studied very well. And then we discovered these mysterious troughs that we didn't know about, and now it's the modelers that are trying to figure out, well, how do you model these things?
Well, that's the best part of these kinds of missions, where it's not just the stuff that you were expecting to find, it's all of the stuff that you weren't expecting to find, and you had no idea that such a thing could even happen, and it goes, as you said, it forces the modelers back to the drawing board to try and figure out what it is that they're looking at. I mean, look at what happened with Enceladus, with these crazy cryovolcanism and these geysers of ice spewing out of the moon. No one ever anticipated that. Or you look at Iapetus with its huge ridge and the sort of dual colors, the bright and dark sides to it. Like, again, not expected. So, I mean, I know there was a few of those kinds of things with Vesta. So what are some of these features on Vesta that Dawn turned up that astronomers just weren't expecting?
Well, I think the most scientifically interesting are the Raysilvia and I'm going to mispronounce this and I apologize, the Venania craters. These are the two giant overlapping basins in the South Polar region. And when I say giant basin, it's very hard for us here on the surface of the Earth, which is a big gravitationally flattened sphere, to just understand how big these craters are. The one bigger basin of these, the Raysilvia, it's 90% the diameter of Vesta. So imagine taking the south pole of the Earth and smashing it in such that when you looked at it, 90% of the diameter got basically tucked back in. This is a crater that's over 300 miles in diameter, so that's a good 6-hour drive. That's right. Pretty much the length of the state of Illinois where I'm living. And then it also has amazing surface relief, and we're not really used to thinking of this degree of surface relief here on Earth. It goes down 13 kilometers, and then it also rises up as much as 12 kilometers on the rim. So if you take the equivalent of sea level for Vesta, the average surface diameter of Vesta, it goes down 13 kilometers and then up 12 kilometers. So you're looking at something that's significantly bigger than any mountain we have here on the planet Earth, even when you go down to the bottom of the ocean and rise back up to the peaks of volcanoes.
I think it's important to say again, right, that there is a mountain on Vesta that is significantly larger than any mountain we have here on Earth.
Yes. And
it's no Olympus Mons, awesome. But it's actually pretty close, isn't it?
Yeah, and what's awesome is, well, Olympus Mons was just a volcano that built and built and built. This mountain was
It's a mountain of a
formed by the
day.
splash of the central part of a crater. So you have rock comes in about 1 billion years ago. The impact energy is transferred into melting the material that made up what is now the South Pole of Vesta. That material splashed up in the center and it froze out into a mountain. And that's just kind of
That,
awesome.
yeah. I, I'm just trying to imagine. I mean, so this is probably one of those situations where before this discovery, if you'd asked planetary geologists, how big an object could you whack into another object and have it still survive? I don't think they would have anticipated this big of an impact. I mean,
I
you
think
know,
it's more
I
a
mean, look what
matter of we
happened that
also
created the
just,
moon, right?
well,
Something, Earth was hit by something the size of Mars and it created the moon.
yeah, we knew that giant impacts like this happened. What startled us was all the varieties of different features that were generated. When you look at Vesta, there aren't any geological elements that aren't affected by this impact. Everywhere you look on the surface, there's wrinkles, there's troughs, there's all manner of different impact-related deformations all over the surface.
Do you have that situation where it hits on one side and then on the what's the antipode, you get a splat like the shockwaves travel right through and then collect on the other side?
That we've seen, there's nothing like that. We do see that on Mercury, but
Yeah.
with this, it actually appears, and they're still trying to figure out exactly how the troughs formed. But when you look at Vesta, there's equatorial bands, troughs, foci, pick your geographic term. Basically, there's belts of ridges and dips going around the equator. Now, it's important to realize that when we say the South Pole crater, that doesn't mean this was the South Pole when this impact
Right.
occurred. In fact, this impact sped up the rotation of this little world. It now has just over a 5.5 hour orbital period. It may have changed, it most likely changed its rotational axis, causing it to be flipped over on its head. This was a dramatic event. And whether it was the spin up that caused some of these troughs due to it spinning so rapidly that material got flung out, or whether these are strictly crumple zones, essentially. If you imagine what happens to a car, it has crumple zones. Well, perhaps this is how the mantle crumpled, and the crust crumpled rather, as the entire planet tried to absorb this impact force. It's just something that modelers are still struggling with, and we don't know if it's a one answer, a two answer, or a more answer way of trying to understand all the physics that happened here.
And I know one of the other questions as well was what is the asteroid itself like? What's its composition? Is it a solid rock, a metally rocky ball, or is it like a loose amalgamation of stuff? Where does it fall on that?
Well, it's here. It's very much like a planet. It actually has the silica-rich metals that not metals, the silica-rich soil materials that we're used to. What I found interesting is this is another world that has a mineral called olivine on its surface, and this is a mineral that requires different waters to be present. There is indications that at some point there were volatiles on the surface of Vesta, so this means that something like comets delivered water, oxygen, other things that sort of evaporate into gas when exposed to the vacuum of space. And over time, these materials in sometimes volatile ways and in sometimes just they evaporated ways, or sublimated is the correct term. These volatiles were lost from the surface of Vesta, but it did affect the composition to have had those volatiles there at some point in the past.
Now, I know one of the big questions with Vesta and with Ceres is that one formed inside the frost line of the solar system and the other formed outside the frost line. So Vesta was the one inside, right?
Yes, so
So,
this is where it had volatiles delivered to it, and then lost them. So far, we haven't explored any permanently shadowed regions on Vesta. As I said, beautifully, everything got shadowed nicely on the northern hemisphere, while the southern hemisphere was well illuminated.
and I mean, are there any situations where you've got places like on the moon which are kept in permanent shadow?
That I know of, I just don't know on this one. There could quite possibly be.
But then so far, I mean, they didn't see any patches of snow on the surface. They didn't see
No.
any, right? So in theory, as predicted, you've got Vesta, which all of its volatiles were either delivered after the fact and or they all, as you said, sublimated away. But in theory, at Ceres, we might see ice.
It's quite possible that the minerals there will be much richer in again, we use the word volatiles here. It's stuff that gets mixed into the composition. So when it formed, it's not quite right to think of it as having ice the way Mars has poles that are big ice caps, but rather the materials that make up the minerals might have waters mixed into the minerals, might have oxygens mixed into the minerals that didn't get blasted out by solar heating when Ceres was in the process of forming.
Now, I know the way this works, right, is the spacecraft arrives at Vesta, does its mapping mission. In this case, it took about a year to kind of gather all of the imagery, and I'm sure it took hundreds of thousands of pictures and tons of data
Yeah.
and all kinds of wavelengths and, spectrometers and all kinds of things. So now the scientists are going to be crunching this data. We saw a lot of the really big, pretty pictures, but what are some of the other kinds of mysteries and information that the scientists are going to be looking for now?
Well, right now what they're doing is they're going through all of the high resolution images and they're trying to map out what is all the crazy stuff that they're finding all across the surface. And this is where Asteroid Mappers comes in, is we're asking everyday people to go in to the Asteroid Mappers project and help us map out where are their boulders, what are the shapes of the different craters scattered across the surface. And we're also looking to find what are the different color variations across the surface. Are there these bright patches? Are there dark patches like we see on the moon? And some of the interesting things that are being sorted out is, for instance, on the moon, we see lots of this gritty, gravelly material, regolith, and this is created by the constant bombardment of micrometeorites and sometimes not so micrometeorites onto the surface of the moon. Well, with the moon, it's fairly big, it has fairly good gravity, and so when a rock comes down, hits the moon, and material splatters up, the splattered material often falls back down to the surface of the moon. But with something tiny like Vesta, you wouldn't expect that to consistently happen. You'd expect boulders to actually get flung off the surface. You'd expect the dust grains and gravel that gets formed to get flung off the surface. So when we do see these boulders, those are events that apparently didn't have huge amounts of energy. And when we see regolith, it's actually confusing. How do you get dust and gravel that doesn't get flung into outer space? And it's now being thought, due to basically some really neat lab research where they're basically baking and freezing rocks, that you can generate regolith simply by the constant day to night temperature
Oh.
fluctuations that the surface of Vesta experiences. This causes fracturing, and over time the material actually just falls apart from constant temperature
So
fluctuations.
it's almost like weathering on the surface of the object, not necessarily from the impacts. Because I know, as you said, on the moon, that's what they thought it was going to be. It was just this constant, steady rain of material that was just chewing up the surface of the moon. Perhaps the same thing could be true over on the moon, that this sort of heating and cooling could also be contributing to the regolith as well.
On the moon, it's probably not going to be nearly as much of a dominant factor. And the moon's rotation is slower, so you're not going to get the sudden temperature fluctuations. With Vesta, you have, again, this over 5.5 hour rotation period and huge temperature variations. And it's basically, think of frost heaves that form on bridges during the winter. This is the equivalent of constantly forming and unforming frost heaves. And over time, just like that cracks pavement, it's going to crack asteroids.
Is that
And so
stuff that
that's,
when you like step on it and it all goes crunch when you're walking down, and the dirt all kind of lifts up and the frost is baked into it? You know what I mean?
no, I don't.
You don't have that there, maybe. Maybe it's just a West Coast thing. Anyway, so Dawn has left Vesta now, so no more of the up close photography and science. Now it's on its way to Ceres. So
Yes.
when will we get that next big update then?
That's going to be 2015, so we're going to have to
Oh,
wait
I
a
can't
while. This
wait.
is a very slow-moving spacecraft. But 2015 is going to be a kind of awesome year for planetary science.
New
We have
Horizons.
New Horizons going past Pluto. We have Dawn at Ceres. Lots of different things going on, so we just need to stay tuned. But it's going to take us a while to get through all the data that was obtained at Vesta. So I wouldn't be too upset about the long wait. There's going to be a steady stream of science coming out from these images.
So we'll just have to keep doing Astronomy Cast for at least 3 more years then.
I don't see a problem with that.
All right, cool. All right, well, that was wonderful. Thank you very much, Pamela.
My pleasure. Okay, save.
So just give us a chance to save our files and put that all aside, and then we'll get on to talking to folks. So save.
No. Okay. Yeah, one of the cool experiments they talked about at EPSC that was trying to figure out things related to much smaller asteroids is there's actually labs where they build cements that are as close to asteroids as they can get, and then they fire guns at them. So one way of doing planetary science is to make cement and then fire bullets at the cement.
That's cool. Firing things at high velocity. Didn't Phil get a chance to experience one of those chambers in his first episode of his Death from the Skies.
Bad Universe.
Bad Universe, yeah. There
Yeah,
was
Phil plays
they got a
Bad
chance.
Universe.
Yeah, he got a chance to they were shooting high velocity impactors at a metal ball, at a stone ball, and it was blasting off chunks. It was really cool. Okay, cool. So I've saved. I think we're safe.
Yes.
So this is good. So now we can relax and just yak with people. So, right. So this is the free-form Ask Your Questions portion of the Astronomy Cast live episode. So all you need to do is you can post your questions. If you're watching this on the event page on Google+, you can post a question there. If you're watching this on sort of the Google+ stream, you can post a question there. If you're watching this on YouTube, you can post a question, or if you're watching this embedded somewhere or on Twitter, you can always use the hashtag AstronomyCast, and we'll be glad to answer both questions about the show we just recorded, or any topic in space and astronomy in general. We're glad to help you do your astronomy homework. We just can't take your test for you. So one question we got actually is from Barry Argo. Did you guys talk about the 2013 comet in previous episodes or today? So Pamela, get ready for the only thing you're going to be talking about for the next year and a half.
Is this the new comet Encke or
Encke?
No, it's not Encke. That's a well-known one.
Elenin. There was Elenin.
So
it's called oh man,
it has a weird name. This is the object that's going to be going stupidly close to the sun and brightening vast amounts, and then potentially
ISON, right?
Yes, potentially breaking into a bunch of different pieces or not. That's the part we don't know, and depending on whether or not it fragments will vary on how bright it gets.
Right, and so what we're getting in is the idea is people are saying the comet Ison is going to be the brightest comet in a century, the brightest comet in living memory, the brightest comet humans have ever seen. So this is I guess this is the exasperated media starting to jump in and get all frothy about this. But you need to put this into context. So you're going to hear one of your friends, since you're the astronomy person, one of your friends is going to say, hey, have you heard about that comet that's supposed to brighten up and be 15 times brighter than the moon? And that's your chance to say, well, actually,
we don't know.
We don't know.
It might get that bright.
Yeah. We don't know what's going to happen. So there's so many variables involved. We know that the comet, based on its current estimates of its orbit, it's going to get close to the sun, probably within about 2 million kilometers of the sun. When a comet gets that close to the sun will often tear it apart and all of those and sort of make it bright. And so you get this great big long bright tail, and it should be really well positioned for the northern hemisphere to be a nice bright comet. If we're lucky, it might just tear it apart and destroy it, or it might just, the comet might not be made of stuff that'll let it get torn apart easily, and so it'll just be a regular comet or not even a very bright comet at all. If we're lucky, it'll be mind-bending, one of the greatest experiences of the year. So I think that's where you need to give this context to people. But I know that people are just going to over-report this like crazy. It's already started. If you go and if you do a search for Comet Ison, Ison, on Google News, you will see that people aren't really putting into context. They're not being conservative about it. They're just being very, very hopeful about what this is going to turn into. So try to manage.
It's being compared to some historical comets that similarly went close to the sun.
But I've never seen estimates this bright. I've never seen estimates for a comet to go this bright. 15 times brighter than the moon?
Yeah, no, that's insane. But it's also unclear how they're calculating that number, because there's lots of ways that you can calculate this number. You can do the total flux from the object, which adds up all the photons coming from the tail, from the head, and all of that light is spread over a large swath of the sky. So when you look at it, it may not appear 15 times brighter than the moon. I highly doubt it'll appear 15 times brighter than the moon.
Yeah, you're not going to be able to read to it necessarily.
Right. So it's just going to be that light is spread all across the sky. And I remember with Comet Hyakutake, it was a good third of the sky that it took up. And when you spread light out over that much space, yes, collectively all of that is visible, and then you add all the light up and then it adds up, but it's a whole lot of moon areas scattered across the sky.
But Hyakutake was an amazing comet, like just a fantastic comet. So if we're lucky, something that will rival or beat the brightness and size of Hyakutake. So let's hope. Okay, so a bunch of questions here. So I've got some Vesta questions, which is great. So Guido wants to know, where in the solar system is Vesta exactly in non-astronomy speak? Whereabouts is it?
It's out between Mars and Jupiter, closer to Mars than to Jupiter.
Closer to Mars than Jupiter. And Ceres is a little further out, closer to Jupiter than Mars, right?
Yeah.
Okay. Okay, so this comes from Eddie Ledbetter. Dr. Gay, exactly how great are the temperature extremes on Vesta that may be causing this regolith-like debris? How big are the temperature extremes?
It fluctuates between, and here let me cheat and actually pull the numbers back up. It fluctuates more than 100 degrees Celsius. And so the example of frost heaves on the highway was.
Have you ever driven on frost heaves on the highway?
Yes.
My wife and I, we did our honeymoon in Alaska, and there's some just hilarious highways in Alaska that you go where I'm sure it all started out nice and straight and flat, but 3, 4, 5 years into it, it's like you're on a roller coaster. It's quite something.
Yeah, and what's neat is you get this nice. They're separated by a systematic distance because of the material basically contracts as it gets colder, and so you have this section contracted, and you get this nice rhythm going as you're going down the highway. So the temperature fluctuations on Vesta go from about minus 188 degrees Celsius to minus 3 degrees Celsius. So it's not quite 200 degrees Celsius span.
Right, but it's a lot.
Yeah.
Okay, so Blake Annenberg asks, paragliding on Mars, yay or nay?
No,
Nay.
not enough atmosphere.
That's the problem. So now, if you built a great big dome on the surface of Mars, and then you pressurized it, and then inside that dome, paragliding would be fantastic.
Yes.
And in fact, something like this was the episode of. Have you seen the episode of Futurama where they go to Mars to?
No, I haven't
like
seen
some
that
kind of.
one.
So there's an episode of Futurama. They go to the moon, sorry, and then people wear winged suits, and then they flap around and fight. It's kind of like roller derby, and but there's actually real science. So the cool thing about this is that if you go and you take a dome on the surface of the moon and you pressurize it, and so you're in 1/6 of Earth's gravity, but you have Earth pressure atmosphere, a human being can generate enough power just by flapping their arms with a wingsuit on that they can actually fly around.
Well, what I think is even more interesting is you can go to Titan and you don't even need to build that dome. Titan already has the atmosphere that you could do your own Icarus flight through the sky.
It would just be cold.
Yes, that's true. So there's no concerns about flying too close to the sun.
Yeah, exactly. So this is a question. I'm not sure. Okay, so John Rear asks, so if Vesta is differentiated, does that make it a better candidate for asteroid mining? That's a really good question, right?
No, ideally for asteroid mining, you want to go out and grab an asteroid that's like pure metal, a differentiated asteroid.
I have one here.
Yeah.
So here, check it out. So I've got an iron meteorite, and so there are actually asteroids floating around in the solar system that are all that. I wonder if they're gold asteroids.
I no idea.
Right. So, but what you're saying, right, is they want to astronomers want to identify asteroids that are solid metal, and then mine those.
Yes. No. Vesta is a nice, large, differentiated object, sort of like the planet Earth, and just like you need to go to different places on the planet to get different minerals. With Vesta, you have different things in different parts of its crust. Let's just grab an asteroid that's already made of pretty much just what we need, and that's a much better candidate.
So as part of our previous question here, Magnus Hustveit wants to know the top 5 most awesome windsurfing lakes and oceans in the solar system. Earth,
Windsurfing?
Earth, yeah, Earth and Earth. I think they all fall on Earth. But no, I guess you could windsurf on Titan, do you think?
I don't think we know enough about Titan to answer that. What's even more interesting to think about is not so much windsurfing as paragliding on Venus, because it has some of the most amazing winds, and the spacecraft that we've sent to basically descend down through that atmosphere have suffered amazing downdrafts and buffeting, and so there's no liquid surface to sail glide on, but you could have fun going down through the atmosphere, except for the whole baking and getting acidic problems.
Right. Well, as long as you stay up in the upper atmosphere, the temperature and the pressure are Earth-like. So you just need to stay up.
Well, and there's all of the acid problems.
Yeah.
Sulfuric acid isn't good at any altitude.
Stay in an acid-free suit, acid-proof suit. But I think, But Titan, I mean, there are plans right now. We actually reported on this week. There's plans to send various aquatic missions to Titan. So a paddle boat has been proposed, and so I think a sailboat would work really well on Titan, depending if there's strong winds.
I'm thinking more one of those duck boats like they have in a lot of different cities.
That's what they're planning, yeah, like a duck boat, like a paddle boat, and it would just kind of it would land in the middle of a lake on Titan, and then it would just kind of ploosh across the lake until it reached the shore. Um, let's see. Okay, so here's a question. Is terraform, it comes from Yasmin Elliott, is terraforming a possibility for planets and asteroids like Mars and Vesta?
Not really. So the problem with terraforming is you can create the atmosphere you want, but if you don't have the gravity to hold on to it, it's kind of pointless. And Vesta and Mars just they aren't big enough to hold on to the type of atmosphere that we'd need.
Um, yeah, that's the problem. I mean, the problem is that even if you terraformed, I mean, we talked a bit about this before on our terraforming episode, that your best bet with Mars is you go and you put some kind of chlorofluorocarbon producer factory on the surface of Mars, and you dump out mountains of this stuff that will then try to sort of warm up the temperature, thicken the atmosphere if you can.
But it's just temporary.
But it's just temporary. That's true. But on Vesta though, it can't really hold an
Yeah,
atmosphere.
Vesta's
So
just kind of pointless.
yeah,
Now, what's interesting to think about with Mars is it's conceivable to grow lichens, to grow molds, to grow other things that may not need a thick atmosphere on its surface. So instead of thinking of terraforming, think of genetic engineering.
I actually find terraforming is a very interesting, almost psychological thing. That we live on a planet that is fantastic, that is perfectly tuned to the great degree to our habitability. And yet I think people would, they like to imagine going and terraforming a place like Mars or a place like Venus, because it's a scientific accomplishment, but also it's a chance to sort of get a fresh start, or
Yeah.
move to a place that isn't Earth and try to do it right this time or something like that. But we would just screw that up too. There'd be pollution, there'd be big piles of, I don't know, pop cans behind your Mars base. So I think that anything that we do here on Earth, that's just a microcosm for what we'll do anywhere else as well. So
Yeah.
it's the same thing as like the apocalypse, like a lot of people have this fantasy about like, oh, it'd be great if there was like the zombie apocalypse, or because I
Yeah.
think they think, oh, it'll be like a fresh start or something. It'd be horrible. Awful, awful, awful,
Well,
horrible.
and the thing
Wouldn't
that
be a
people don't think through is we've already used up all of our readily accessible minerals and
yeah,
oils and other fuel sources and well, building supplies. So if we destroy our environment and destroy technology, there's not going to be a second Bronze Age because well, there's no readily accessible bronze. There's not going to be a second petroleum age. There's no
right.
easily accessible petroleum.
Yeah, and I think there was a Spider Robinson book about this a couple of years ago, that was sort of on that idea that they they never you never get a second chance,
Yeah.
because we've gotten all of the easily accessible, the step ladder material, with there's ore sitting on the surface, there's oil bubbling up. We're now at the point where only a highly industrialized civilization can get access to these things that you need to become a highly industrialized civilization. So if we fall off the train this time, we probably won't be able to get back on.
Yeah, Orson Scott Card's also written about it.
Yeah,
It's one of those things many science fiction writers are starting to have these panicked realizations about.
yeah. Yeah, Brian Simpson says mining landfills is the business venture for the next century.
It,
Exactly.
it is, and this is already taking place in other
Yeah,
nations.
yeah. This is already happening. Um, so Griglet just asked on YouTube, with the comet Ison, how will it compare to when Hale-Bopp came by? So as we mentioned, either fantastically, amazingly better, or fantastically, amazingly worse. We don't know. There's too many variables until it actually goes past the sun. So we've got to wait till 2013. It's exciting. Mentally prepare
Yeah.
yourself to walk outside and look up, but we
There,
don't know what's
there's
going to happen.
two confusion points with comets. One, they can fall apart, in which case you just end up with a lot of small pieces that glow nicely but don't add up to a lot of light individually. And the other problem is you can also get comets that are coated in materials that cause them not to develop big, beautiful tails and to not get all nice and shiny reflective. So they can be duds and they can just fall apart.
Okay, this is a great question. I love this question. So Nick Rutledge asks, if both of you could greenlight one already proposed unmanned space mission, which probe would you choose and why?
Terrestrial planet finder.
Terrestrial Planet Finder. Our fans would know that would be our answer. For those who don't know, the Terrestrial Planet Finder was a mission that was proposed, I guess, 10 years ago.
Yeah, something like that.
And the goal was it would be sort of like a super duper James Webb telescope. And it would have the ability to resolve the disks of extrasolar planets. And it would also be able to detect atmospheres of those planets and figure out what they're made of. And that's really important because if you can detect oxygen or pollution in the atmosphere of planets, then that just tells you that there's life there, pretty much. So, in other words, this would be the Alien Finder telescope. And we
Yeah.
thought that would be really important to build, the Alien Finder telescope. Yeah.
But Congress didn't agree.
No. So, if at some point anyone wants to take up our suggestion, we highly recommend you build. Maybe they just gave it the wrong name, right? They called it the
It's
Alien
true.
Finder. Right? 'Cause that's what it
Unfortunately,
is.
NASA has a habit of not looking for aliens. I think there's actually a congressional ruling against it.
Mm-hmm. Yeah, you can't do that, but we can with
That's
CosmoQuest.
true.
Yeah, we'll find aliens. All right. Elaine Martins wants to know: is it possible to see Vesta from Earth with an amateur telescope?
Yeah, totally. It was actually found with a fairly amateur level telescope. So
Yeah.
yeah, go for it. It's easy.
Yep. Easy.
Yeah, actually it is. You just take a whole series of images and the sucker's plowing along through the sky. Fairly easy to see. Let me see if I can find a brightness on it real fast. I want to say that it's accessible with a 4-inch telescope and a nice camera. Yeah,
Yeah, you
it,
don't
it
you don't
varies
need.
from visual magnitude 5.1 to 8.48. So this is something you can see with binoculars. The only problem is it just looks like a boring star unless you know what you're looking for. So I'd say 4-inch or larger telescope and some sort of camera is the best way to go looking for it.
Right,
Take
and
a
ideally
series of
take
them.
one picture one night and then take another picture the next night, and then you
Oh,
should be
not
able
even the
to.
next night. Take it 10 minutes later, 20
And you
minutes
should see a
later.
little bit of movement in your
Yeah,
feed. Yeah,
asteroids are near enough that you can see them moving very readily.
there you go. We actually did that one time in our virtual star party. We had
Yeah, with Mike Rector and I were watching Iris.
that's right, yeah. Um, Mike Phillips.
Yes, you're right.
Yeah. Okay, so Brendan Hess wants to know how much force does an ion engine put out?
Very little.
This much force, isn't it? Isn't it this much force?
Pretty much, yeah.
Yeah. So it's the amount of force of a piece of paper sitting on your hand. The trick is that if you just keep it running for months, and so it just builds up the velocity over a long period of time.
And force in this case is really kind of the wrong way to think of it. It's a conservation of momentum thing. You fling an atom out one side at a high enough velocity that the spacecraft, due to conservation of momentum, moves in the other direction.
So I've got a bunch of questions here, sort of in the same front, which is, could we smash asteroids into Mars to thicken the atmosphere?
No.
No. And then
Comets,
people
maybe. Comets are more useful. Asteroids, you're just smashing rock.
into
Rock
rock.
begets rock. If you smash comets into it instead, you end up releasing a lot of volatiles, the word of the day, apparently.
Yeah.
And this is actually how we think at one point in the past Mars had liquid oceans on the surface, had a much thicker atmosphere, and it was due to the bombardment from comets.
This is a good question. So the inventor mind asks, could we take one of Jupiter's moons and put it into a different orbit so that it would make a new planet? Now, I think taking anything away from Jupiter is not done lightly.
No, that's an energy intensive and very expensive notion.
But
Um,
what about taking, something like Ceres or Pluto, which are Jupiter moon-sized objects, and bringing them right into the inner solar system?
If you did that to Pluto, it would grow a rather undignified tail and behave like a comet, which is no way for a planet to behave.
And now you're just Neil deGrasse Tysoning us your answer here.
That's actually Mario Livioing it.
Oh, is it? Okay,
Yes.
all right. But would it, or no, I mean, wouldn't it have to be closer to the sun than the orbit of, say, Earth? Wouldn't it just melt?
Yeah, yeah. So you'd want to grab something rocky. So if you grabbed Ganymede, if you grabbed Io, so grab one of the rocky objects from the outer solar system. And these are, again, planet-sized things. Ganymede's very much planet-sized, planet behaving, except it happens to be orbiting Jupiter instead of the sun. And this is where it's curious how you start defining things from a geological perspective, and this is where you'll often hear me and others refer to these as terrestrial bodies or worlds or other nouns that get rid of the concept of planet and simply refer to it as a geological object.
I think that would be actually a very interesting experiment to do. Take Ganymede, pull it away from Jupiter, move it into the inner solar system, and
You'd
see what
have
happens.
another Mercury. It would be a quite boring object.
But it would have, well, okay, so what about like Callisto, which seems to have water on the surface?
It would lose it.
Not quickly, though. It's got enough gravity to hold on to it. Like, it wouldn't lose it overnight. It would lose it over a billion years.
It would probably lose it much faster than that, but no, it wouldn't lose it overnight.
Yeah, 100 million years.
So you have a slowly evaporating rock.
Perfect. Perfect. Just what
Not
we
sure what
wanted.
it's perfect for, but okay.
I don't know, for the best, the best. Someone wanted the best windsurfing location in the solar system.
But it
and
has
that
no
would bring it.
atmosphere, so it will have no wind.
True. All right. Let's see. Man, there's a bazillion questions here. Okay, so Fadia Lakuget asks, what could have caused the parallel grooves or streaks on Vesta's surface? So I don't know if anyone has seen those pictures. Do you know what she's talking about?
Yeah, so when you look at Vesta, there's we refer to them in the show as troughs and rifts, basically. They're crumple zones, as near as we can tell. Vesta got smacked by something large and spun up, and it's a combination or one or the other of the spinning caused the troughs or the crumple zone of it getting hit caused the troughs. We're still trying to figure it out.
Next question. Cam Balakut asks, could the water on Mars have been lost to space during the smaller gravitational pull of the planet?
Could you say that again?
So I guess Cam is asking about the water, that there was once water on Mars and now that it's gone, and wants to know, could that be because of the lower gravitational pull of
that's exactly what it is.
Exactly, yeah. Well, it's two things, right? It's the lower gravitational pull and the lack of a magnetosphere to protect it from the solar wind.
The lack of a magnetosphere accelerated the process.
So Callum Combs asks, have they confirmed the Mars quakes that we were talking about in the Weekly Space Hangout?
I don't know.
I don't know. No, I mean, I think this is one it's going to require a mission, and there is a mission planned, and we won't be able to confirm them until that mission is done. What is it, the InSight mission? Is that the one?
I'm not sure.
There's a new spacecraft that's going to be sent to Mars, and part of its job is to detect the seismology in Mars. And so we won't know until that mission has been created and launched and landed and has done its research. I think maybe I was talking to Emily about that.
Yeah, you did this the weekly science hour a couple weeks ago.
We did. Yeah, we talked about curiosity. Okay, cool. Well, I think we're starting. Let's take one more question here.
Okay.
Bill Keller asks, how long is Dawn projected to orbit Ceres, and is there an extended mission plan for it, and anything else close enough to visit? Actually, that's a good question, right? So one, how long will Dawn hang out at Vesta? Oh, sorry, at Ceres? Forever? Till it dies?
Until they decide to move it, basically. So this is one of those cases of it gets to Ceres and then they can go into extended missions, then they can start looking into considering moving it somewhere else, and there's many different possibilities.
And so I guess that's the question, right? Will it still have fuel in the tank? Will it be able to move on to some other object? Can they extend it to a third asteroid to
I'm
examine?
not actually sure on that. I have to admit, I tend to take the pessimist's view and only look one object ahead at a time.
Right. But what's important, I guess, is that unlike, say, the Mars exploration rovers, which were solar powered and able to move until their motors wear out, uh, in order for Dawn to reach a new object, it's got to use this ion engine, which is these charged particles of xenon that it kicks out
Right.
the back of it. It's going to run out of atoms of xenon to throw out, and so that's going to really limit how far it can get. But they're clever, those NASA engineers. So who knows how far they'll get. Cool. Wild Hydra wants to know, hey all, is this live? Yes, this is
Yes.
live. This is live. So, and this is it. We're done. So, well, once again, thank you very much, Pamela, for taking the time to do the show and to answer all of the questions. That's absolutely fantastic. Everyone can see Pamela's brain working in real time, which is great. So what are we doing next?
The
Weekly Science?
weekly science hour is Wednesday at 4 p.m. Pacific. We're still sorting out what it is this week. Then Thursday at 10 a.m. Pacific is the weekly Space Hangout, which is a roundup of this week's news stories. Sunday night, as always, is our virtual star party. And then rinse and repeat.
Rinse and repeat. Do we have a plan for next week's Astronomy
No, we
Cast?
don't.
No, we don't. Oh well, by all means, throw your suggestions for some show ideas into the comments wherever you're watching this, and
I know what we should do.
if one of them inspires us, we will add it to the list.
We should talk about the Exploration Day and various great explorers, because it's Columbus Day, and let's erase Columbus Day with Exploration Day.
Somebody also suggested Newton, which I think is actually a pretty good topic we haven't done yet.
Okay. Is there a spacecraft named Newton?
Yeah, the XMM Newton.
Oh, that's right.
Yeah.
Yeah.
So there's a mission, and it's cool, and there's a guy, and he was weird. So I think there's a lot of good topics to go. So that would be my proposal. But anyway,
Okay.
if anyone wants, by all means, kick some suggestions into the comments wherever you're watching this, and we'll be glad to incorporate them. So thanks again. Thanks for watching. Thanks for commenting, giving us questions. Thank you, Pamela, and we will see you all next time.